Yes,
So in this way, we'll be doing questions. In question number 1, spherical nodes in 3p will only be 1. And the shape of the orbital, as I told you, for spherical or radial nodes, n minus L minus 1. This is spherical or radial nodes. And for angular or planar nodes, formula will be L only. So spherical nodes 3 and L is equal to 1 minus 1, 3 minus 1 minus 1 will be equal to 1. So answer will be this. And in second case, this is dz square. So d orbitals are double shaped, but dz square is donut shaped. But here donut is not there. So obviously what you will be writing, you will be writing double shaped. Now see what I'm talking about. I'm
yes,
talking about third question. Hydrogen, you have to write the fourth quantum numbers value of valence electron of this rubidium 37. Hydrogen, lithium, sodium, potassium, rubidium. So this is 1s1, 2s1, 3s1, 4s1, and this one is 5s1. 5s1 means
5s1,
n is equal to 5, n is equal to
5,
5, L is equal to
0,
0, M is equal to 0, S is equal to
equals to
plus
0,
half or minus half.
half,
Plus half
yes,
or minus half. So C
yes,
500, 500. This is the only one. A. Fine. You should check all
yes,
these answers, and if some mistake is there, if some wrong answers you are getting, if you are having any sort of confusion, just please let me know so that I can explain this one. Now
yes,
see, now see, now see. The electron identified by quantum numbers n and L are. The electron identified by quantum numbers, the electron identified by quantum numbers n and L. So I don't know what is the question. I think they are asking here energy level. I'm not sure. From answer only we will come to know what the answer of question number 4 is. 4 is B. B. So
B,
from answer, we will come to know that what question they are asking here. B. This is B. This is B. B, fourth is minimum. Fourth is minimum. Second, then third, then first. C. Energy is equal to N plus L rule. N plus L, that is 5. N plus L, 4. N 3 plus 2, 5. 5. And N is equal to 3 plus 1, 4. See here, these two are same values, are having same values. Which one is having higher N value? First one is having higher N value, so will be having highest energy. Will be having highest energy.
so 4P,
Then yeah, whatever it is, 4p or 5p, whatever it is, just see n plus n value. So now see what this fifth
sir,
5 is. That is 3 plus 2. So third will be lesser than first. Then these two are having same n value, n plus l value, which will be having higher n value. Higher n value will be possessed by the second one. Then
the
second.
second,
Then lesser than that is fourth.
So they both
first,
have the same n value, 4 and 2. So they
Four.
both have the same n value.
In which case?
The 4 and 4.
4 and 4. No, B, and you are talking about B and D, or what you are talking about? You are talking about first, second, third, fourth. So which two you are talking about? Second and fourth?
The first, second.
First and second. Fine.
Yes.
But L is there in first
so
case,
first
na?
and third.
Okay. Yes, sir.
Fine. If N is higher, then we'll be having more energy. And if N plus L is higher, then we'll be having higher energy. But if N plus L is same, see in this case 5, and in this case also 5. So which is having higher n value? This is having higher n value, so will be having more energy. So we'll be having higher energy. Now see here, 4 plus 0, 4, and this 3 plus 1 is equal to 4. Both will be having same energy. Which will be having higher n value? This will be. So we'll be having higher energy. So first is having highest energy, then third, then second, then fourth is having the least energy. Is this okay? This is very, very important question. Is it okay?
Yes, sir.
Should I go to the
Yes,
next
sir.
one?
Yes, sir.
Fine.
Yes, sir.
Fine. Okay. Now go to the next question. All these questions I have taken from your unsolved papers, from previous year's papers, NEET and IIT JEE. From there only I have taken all these questions related to these. All questions are based on nodes, shape of orbitals, and the quantum numbers. Maisha, have you done all these questions?
Yes, sir. I have tried all these, but there was some problem in a few questions.
Okay, fine. So you should let me know where exactly you are having problems. So I'll be mentally prepared for this class, and accordingly I'll be explaining. If I won't be teaching you quantum number, then also I'll be explaining, I'll be clearing your doubts. So always let me know. Asta messaged me yesterday night only that this is her problem, area of
Yes,
concern. So accordingly I was mentally prepared and I took this all first. So always message me if it is zero now. If you'll be getting zero, then also let me know. Need not to bother. If we'll be knowing 100%, then need not to sit there in this classroom now. We will be taking
yes,
rest.
sir.
Since we are not perfect, that's why we are taking classes, that's why we are discussing this all. So if you have any issue, then you should let me know. Then only I can come to know, then only I can help you. You must be bold enough. Which of the following sets of quantum numbers represents the highest energy of an atom? So now same value, 4, 5, 4, 3. So which will be having highest energy? B. Which will be having highest energy? B. Then lesser than B will be A,
Sir, B.
then C, then D.
B.
Highest energy will be possessed by B. Let's see, let's check whether
B.
this answer is right or not. Which question it was? Fifth one. B, A, C, D. B, A, C, D. B, A. Highest energy. B is having highest
Sir,
energy.
answer is
Fifth
B.
answer is B now. That's right.
Yes, sir.
Okay, fine.
Yes, sir.
In a multi-electron atom, which of the following orbitals described by the three quantum numbers will have the same energy? Fine. Just a minute. Just I'll mute my. Sorry, I was feeling thirsty. So now this fifth question is also over. Now sixth question. In a multi-electron atom, which of the following orbitals described by the three quantum numbers will have the same energy in the absence of magnetic and electric field? So which three orbitals will be having, which of the following orbitals described by the three quantum numbers will be having the same energy? See here, this printing mistake is there. N is equal to 1, L is equal to 0, M is equal to 0. Fine, which will be having same energy. This these two will be having, just a minute please. So see here, I think there must be n must be equal to 1. If it is 1, then only these two and these two will be having same energy. So
Same energy.
Sir, I didn't
fourth
get
and
this
fifth,
question.
first and second. So what answer they have given?
So option A.
Option A. Option A, fourth and
Yes,
fifth.
sir.
Fourth and fifth, है ना?
Yes,
So then this won't be 1.
Yes.
This won't be 1. It will be other than 1. This won't be 1. So these two will be having same energy. Is it okay?
Yes, sir. Yes, sir.
Sir, could you please explain?
See here, this is first shell. First shell is subshell 1s. If you take this also 1, n is equal to 1, then this will also become 1s. Then both will be having same energy. But answer given is this now. It means that this is not 1. This is something else. This we can write here 2. Here you can write 2. So these two can't be. 1s and 2s can't be having same energy. No? We'll be having different energy. This is 3d. This is also 3d. So all the 5 orbitals will be having same energy now.
Yes.
Orbitals having the same energy. So these two will be having fourth and fifth will be having same energy. Is this okay?
Yes, sir.
Now see the next one. Question number 7. Which of the following sets of quantum numbers is correct for an electron in 4f orbital? This is correct. Fine. This can't be correct. N is equal to 4, L is equal to 4 is not possible. L can be 0, 1 or 2 or 3. 0, 1, 2, 3. So this can't be true. N is equal to 4,
Yes.
L is equal to 3. L is equal to 3. This is also
Yes,
not
sir.
correct because L is equal to 3. So M will be plus 3 to minus 3. L is equal to 3 now. So M will be plus
Yes,
3
sir.
to minus 3. This is also not
Yes.
true. N is equal to 4,
Yeah,
L is
answer
equal
will be
to
correct.
3, M is equal to plus minus plus 1, S is equal to plus 1. This is right.
Yes.
This is right. Now see the
Yes,
next
sir.
one. N is equal to 3, L is equal to 2. L is equal to 2, then M is equal to minus 2. S is equal to plus 1.
Sir, it may also be correct.
C and D both are correct. Oh, sorry. They are asking about
Yes, sir.
4F now. They are asking about 4F. This is 3D.
Yes, sir.
This is 3D and this is 4F. This is 3D and this is 4F. So this one is the right one. L is equal to 3 is 5 F now. L is equal to 3 is F now. So 4F.
Yes, sir.
So that's the answer. Fine. L is equal to 1. L is equal to 1 means P electron. L is equal to 2 means D electrons. So just write down the electronic
Yes, sir.
configuration of chromium. Chromium 24. Chromium 24. Electronic configuration will be 1s2, 2s2,
1s2,
2p6,
2s2,
3s2,
2p6,
3p6,
3s2, 3p6,
4s,
4s2,
1,
3d4,
3d. What it is? Chromium na 3d5. 3d5. So 2, 4,
Yes,
10,
sir.
12, 18, 18, 19, 5, 24. Now see, L is equal to 1 means P. How many P? 6 and 6, 12, 12 P.
Sir, 12.
So 12 are 2.
Yes.
Now P is over. Now D. D is 5.
Fine.
T is 5.
Answer will be D.
So 12
Yes.
and 5. This will be the answer. L is equal to 1 is 12 and L is equal to 2 is 5. L is equal to 2 is D now. L is equal to 2 is D. L is equal to 2 is D subshell. So in D subshell, 5 electrons are there, and in P subshell altogether, 12 electrons are there.
12
Okay,
electrons.
Mesha, is it okay?
Yes, sir.
If it is not clear, means if still you are having any issue, even tomorrow or day after tomorrow, any day you can ask me. Fine?
Yes, sir.
Any day you can ask me. Now see, N and L values for some orbitals are given, which will be having least value, least N value. This is having least N value now. So we'll be having least energy.
Yes, sir.
So this will be the answer, least energy. Fine, least energy. Now see, if N is equal to 4, then how many orbitals will be having L is equal to 3? L is equal to 3. L is equal to 3 means F subshell. F subshell. F subshell. In 4,
Sir, 7.
7, B will be the answer.
Yes, sir.
7, B will be the answer.
Sir, can you explain this one?
See, principal
I
quantum number
think
N is equal to 4 now. N is equal to 4.
Yes, sir.
N is equal to 4. N is equal to 4 means F subshell. Na? N is equal to 4 means F subshell. And in F subshell, L is equal to 3 means F subshell. Na? So if
Yes, sir.
F subshell, we are in the 4th shell. So 4F. And in 4F or any F subshell, how many electrons can be accommodated?
7.
14 electrons can be accommodated, and number of orbitals will be 7. So here they asked you number of orbitals. So that will be 7. That will be 7. Now see next question. This was 7. Now see question number 11. Question quantum number M. Quantum number M, that is magnetic quantum number, that is related to orbitals only. That's related to orbitals only. So this is related to, this magnetic quantum number is related to orientation of the orbital. What the answer they have given? M atom is associated with the orbital spatial arrangement of orientation of the orbital. Question number 11. 11 is C, the spatial arrangement of the orbital. Azimuthal quantum number. This gives you an idea about the
Sir, angular momentum of electrons.
angular momentum of the electron.
Yes.
Azimuthal quantum number defines the azimuthal quantum number, angular momentum quantum number. Fine. So
Yes.
12,
Yes, sir.
B will be the answer. Then 13th. The total number of orbitals in a shell with P, Q, and N is. Number of orbitals na N square. In previous
Sir,
class
N
only,
square.
yeah, in previous class only I explained you when it will be 2n square and when it will be n square. So fine. Now see, this question is also over. The 2 electrons occupying the same orbital. This is S is equal to plus half, and this one S is equal to minus half. So two electrons occupying the same orbital are distinguished by a spin quantum number. You are not getting this question now, Asta? Which question? Which two questions it was?
Yes, sir. Sir, 15th.
15th. 14th also,
Sir,
na? No.
15th.
15th and 11th.
No, sir.
Only 15th.
Yes, sir.
Okay, fine.
So 15th and 11th.
And what about that question, baby? Homework question. Do you remember that? Once upon a time,
Yes.
I gave you one question now.
Yes.
Do you remember that? But you didn't say
Yes.
anything. But you didn't say, none of you said anything about that question. Fine,
Sir, I
not an
tried
issue.
it, but
Yeah,
I
then
forget,
the
sir.
answer.
one thing I want to tell you, that question in no book you will be getting. That is my personal question. I made it.
Yes,
I
sir.
compiled it. So nowhere in no book you will ever get, even in IT, JEE, etc. too. That's my personal question. So if you'll work very hard now, I'll prepare many such questions from all these different topics. So fine, this is over. How many electrons can fit in the orbital for which n is equal to 3? N is equal to 3 and L is equal to 1, 3p. So what will be the answer? 6, 10 or 14? In 3p, how many electrons can be accommodated?
Sir, 6.
6. Very good, baby. Masha,
Yes.
how many? 6, 10 or 14?
The 6.
But
See,
sir,
ma'am.
answer is 2.
Yes, sir.
See what this is.
Orbitals.
And in
Sir, orbital.
and in an orbital, how many electrons can be accommodated?
2.
Already yesterday or day before yesterday, I discussed this question. I think yesterday I discussed this question. If orbital is written now, whatever else is written here, leave this all. If orbital is written, if you are talking about the orbital, then in that orbital, maximally how many electrons can be accommodated? 2 electrons can be accommodated. Is this all okay? Should I go to the next one?
Yes, sir.
Fine.
Yes,
So this question paper was also my personal question paper, means nowhere else you will get questions based on quantum number like this. Fine. So now we will be sharing another screen, atomic structure we are doing now. So atomic structure. So till spin quantum numbers, it is already done now. See this last question paper na, in that paper it was there na, number of orbitals in an orbit is n square and number of electrons in an orbit
In
is
an orbit
2n
is
square.
2n square.
Fine. So everything you will be getting from my contents only, from my notes only. So read this all very carefully. Now quantum number is over. Now our next topic is atomic models. What our next topic is? Atomic models. What our next topic is? Atomic model. So see, this is also a very big topic, and in this topic we will be talking about various atomic models. In this topic we will be talking about various atomic models. See, this is screen number 24. Screen number 24. Now see, fifth topic from this chapter, atomic models. First is origins of atomic theory. Origins of atomic theory. John Dalton, J. L. Gay-Lussac, and A. Avogadro. Experiments were quantitative measurements based on weight and their postulates, mainly concerned weight as a fundamental atomic property. C. John Dalton, Gay-Lussac, and Avogadro experiments were quantitative measurements based on weight and their postulates, mainly concerned weight as a fundamental atomic property. As a fundamental atomic property. So after 3-4 minutes, after 10 minutes, this class will be stopped. So we'll reconnect again. Now see, Now see there in this atomic model or origins of atomic theory, first topic is John Dalton's atomic theory, 1808. John Dalton's atomic theory, he gave this theory there in the in the time of 1808. Tomio, atom mainly is derived from Greek word tomio, Latin word, sorry, tomio. Tomio means divisible. Since atom is indivisible, so they gave that particle name as atom because atom was indivisible and tomio is divisible. That is a Latin word. Now see what according to Dalton's atomic theory is. Dalton's atomic theory, which was given by 1808, according to this Dalton's atomic theory, atom is hard, dense, smallest particle of matter. These questions are already, these points you have already done. This topic, this Dalton's atomic theory, you have already done there in the some basic concepts of chemistry and in 9th and 10th also. Atom is hard, dense, smallest particle of matter. Atom is hard, dense, smallest particle of matter. That is, you can say, structureless, indivisible particle. Atom can neither be created nor be destroyed. Atom can neither be created nor be destroyed, and during the chemical reaction. Atom can neither be created nor be destroyed during any chemical reaction, but in nuclear reactions it can be destroyed or created, as I already told you. In nuclear reactions, atom can be destroyed or can be created, but in chemical reactions, atom can neither be created nor be destroyed, will remain the same. Atoms of different elements. Atoms of different elements. For example, argon, weight 40, calcium, weight 40. Argon, weight 40, calcium, weight 40. Now see here, these two different elements are having same weights, means their properties are same. So atoms of different elements are different and atoms of same elements are alike. Atoms of different elements are different and of same elements are like in physical and chemical bonding. Atoms always combine in whole number ratio. Atom always combine in whole number ratio to form compounds. From a strong basis for understanding stoichiometry, the quantitative laws of chemical combination. So this is another postulate of this Dalton's atomic theory. Then it explained the law of conservation of mass and mass. It explained the law of conservation of mass and some other laws of chemical combination, such as law of multiple proportions. So this Dalton's atomic theory explained the law of conservation of mass and some other laws of chemical combinations, such as law of multiple proportion. Now, drawback of Dalton's atomic model. Fine. So now we'll go to the next screen. After this, Dalton's model. Drawbacks. This Dalton's atomic model. This Dalton's atomic model fails to explain why atoms of different kinds should differ in masses and valency, etc. Why different atoms should differ there in masses and valency, etc. This Dalton's atomic model does not explain the structure of atom. This Dalton's atomic model fails to explain binding forces between atoms and compounds. This Dalton's atomic theory does not explain Gay-Lussac's law, and the law of definite proportion fails if different isotopes are used. If different isotopes are used there in two compounds, then law of definite proportion will be failed and law of definite proportion will be failed. Now, this Dalton's atomic model does not differentiate between atoms and molecules. The discovery of isobars and isotopes showed that some of same elements may have different atomic mass. Isotopes and atoms of different kinds may have same atomic masses. So this point you will be again studying there in isotopes, isobars, and isotones. So this was about the drawbacks of Dalton's atomic model. What next is Thompson's atomic model, that is also known as plum pudding model. This is also known as plum pudding model. Thompson's atomic model. According to Thompson's atomic model, atom is a hard sphere of positive charge particles. Atom is a hard sphere of positive charge particles uniformly distributed with the electrons scattered as points. See, this is a hard sphere of positive charge particles uniformly distributed. Fine. Since atom is the hard sphere of positive charge particles uniformly distributed with the electrons scattered as points throughout the sphere, plus and minus are uniformly distributed, known as plum pudding model. However, scattering experiments studied by Rutherford and Martin. In this experiment, we came to know about the radius of the atom, that is 10 to the power minus 10 meter, and this nucleus will always be positively charged, and their positive charge must be equal to negative charge. Drawbacks of Dalton's atomic model. According to Dalton's atomic theory or atomic model, photoelectric effect and thermoionic questions could not explained. Photoelectric effect and thermoionic emission could not be explained. Alpha particle scattering experiment by heavy atoms could not be explained. These two things, according to Dalton's atomic model, could not be fine. So, alpha particles
Yes, sir.
experiment and the photoelectric effect.
Sir,
These two-
thermoionic emission क्या होता है?
See, this is a metal plate. If you'll heat, then electrons will start emitting from this metal plate. So because of this heat only, electrons are emitting. So that's called
Electrons are
thermoionic
emitting.
emission. Fine. Now we'll go to the next
Yes.
one.
Yes.
Now, Thompson's model and Dalton's models are over. Thompson's model and Dalton's models are over. Now, what next is that Rutherford's nuclear model of atom. We'll discontinue this class and we'll restart again. Fine, we'll rejoin it again. Now, see, I'll stop this video over here, and then we are in the next video. Fine, so we'll reconnect. We'll reconnect just in seconds.